Hey, so, everybody talking nowadays about the outage with the Microsoft and the null pointer mistake and so on. To be honest, to me, it's not null pointer mistake, it's the engineering processes mistake and the testing. So it doesn't matter. You couldn't blame the language because, every languages have some downsides and benefits and so on. But today, I want to record this video and talk a bit about this $1 million mistakes in a programming language design. It's not actually my um, specialty topics, but I wrote the article a long time ago. And on top of the list for sure it's nulls because it's cost a lot. And it's multiple production use cases where null really make us the trouble. And a lot of languages doesn't have the concept of the null at all. And so, for example, you could use the monadic interfaces. Java and C# have the options. You could use the maybe monad. You could use even more advanced things like dependent types and move more logic to the types that are null free. So we have the multiple ways how to avoid nulls even in a programming languages that actually doesn't have this concept out of the box. So you could connect libraries that have something like option and maybe. And in JavaScript right now we have the optional chains. It's still far from perfect, but still quite good. The second one, actually, for sure, the next $1 billion mistake is the error handling. And the error handling and exceptions. Exceptions was the horrible idea in general. So exceptions is just a nightmare. And yeah, so how we could do it better? First of all, again, the monadic interfaces, you could use something like either to return the error as a value and make a code aware about this error. But the downside of this approach that you just shift the problem, right? So right now everybody should check if it's the error and all those things. How we could do it better, because with the uh, try catches you have this bubbling of the errors and all other things. So it was quite hands-on, and how we could have it in a much better way. So the much better way actually it's the algebraic effects. So with the algebraic effects you could have something powerful that allows you to decouple the error from the error handling. But with the algebraic effects we fixing yet another uh, $1 billion mistake in a programming languages called the coloring functions. And if you do the JavaScript, for example, for a long time, you have this problem that you have a function that marked as a async, and then if you have some functions that use this function too, then you need to mark them async too, then you start coloring your functions and all those things. So algebraic effects actually capable to do the asynchronous logic together with the error handling, together with much more, even together with the dependency injection in a one shot. And how it's work that you have a fibers instead of the call stacks, and you could have the coroutines and pausable executions and all of the things, and you actually could see the algebraic effects as an error that have the ability to continue, and it's extremely powerful thing. And OCaml have this some dialects of the Smalltalk have it, effect language have it, and all the things. And I really keen to see the effect handling in a core of the JavaScript language, for example, in the future. So, and yeah, we have the nulls, we have the error and error handling, we have the asynchronous functions and concurrent programming. So we talk about all this. It's super easy to make the mistakes there. And in general, if you're talking about the parallel and concurrent programming, so the biggest problem of the languages that design the concurrent programming actually, it's the mental model or the cognitive load, because it's super hard to do the concurrent programming for the human brain. And that's why I believe that, yeah, the algebraic effects helps a lot, but still maybe we could have some abstractions that help us to do it better. And one of such abstractions actually is just avoid the concurrent programming at all and have some kind of schedulers that do it for us, like channels in Go or actor models in Elixir or in a Erlang. So they just hide all this complexity on the cognitive model that are simple enough, and then you could focus on the single actor, that single threaded, and so on. The last piece of challenges in a programming language design that cost us a lot of the cognitive load and money for the business. Actually, it's the duality of the classes and objects, and this problem was visible in Smalltalk. There was the working group that gets together and make the programming language self, and they say that fragile classes, class hierarchies, and all those things is too much and too expensive and too fragile. And they came with the idea that you have the objects and prototypes. And prototype is just the instance of the object. So on practice, you just have the objects that chain each other together, and it's how the JavaScript was working for decades and so on. So the prototypes is not the weird guy in the room. The prototype is the answer to the fragile classes problem. So it's yet another really smart thing that you should reconsider if you're doing the JavaScript actually. So that's all that I was keen to share with you today. And try to avoid these mistakes. Try to use the languages that really careful about the memory. Try to use the languages that really careful about the multi-threaded programming. And if you work in some domain that are hardware specific, it's a one story, then maybe Rust could help you. If you're working in something so fragile like TypeScript and JavaScript, maybe you could consider some better libraries that have more functional and monadic approach that try to avoid nulls, try to avoid errors, try to avoid trackages and all the things in a first shot. And maybe classes are too complex. Maybe we should use something more simple. And that's it that I was keen to share with you. Please subscribe to our channels, write the comments, and give it a try to slightly different approach to the programming.